Couldn't finish microwaving before we started.
Yes, please.
So I will do a quick run through on important stuff, and it will also help us focus your questions and how to study further. Okay, so and that algebra. This is the test. Also connect with algebra. Okay. So first of all, the structure of the test, it was on the very end of the file. I'll remind you, this is indeed the structure. Oh, now I'm noticing that I didn't write on the test the number of points. Okay, but that's the number of points. I wrote it only for the first question. I think I forgot to do it on the rest. Hopefully I didn't write 34, but I think I simply forgot to write the number of points. Okay, but it's that.
You haven't priced it yet, I'm guessing.
Yeah, but it's a whole thing. I'm already pretty late submitting it now, so they will kill me if I tell them to change it. I would rather give you more points than to go to the exam.
I'm okay with that.
No, but that's the same, and I think it's clear in the sense that the first three questions are 3 sections each, and the fourth question is 2 sections. And so that's the structure. The first include a system of equations with a parameter. That's the least surprising question. The link I've given you, let's see, I'm supposed to find them easily because I did this today. The 2 times I gave you links. Just a second. Oh, this is this is the review session. The questions in the review sessions are good, I think. Oh, and I have a comment, an important comment now that I'm going over it. This is the review session. Okay, so first of all, before I find the links, I when I went through the lecture, I noticed this irregularity. I said note here. Oh, and these are the one of the links. Also, I put it 3 times. So this is skip verification. Yeah, this is from the teachers, and this is and chemistry are both of the links. So here, if I enter the link, question number 3, you ought to know how to solve, and you have a intersection of subspaces, and here I wrote, we've learned. Note, I did not teach you how to find the base for intersection. And then I've started teaching it. And I said, we've learned 2 ways to present a subspace, either by span or by the solution to a system of equations. And from which approach it's easier to find the intersection. And then I said span is not good. And then I've shown you that the algebraic is good, but I didn't write it, right? But that's important because I'm asking about intersection in the test, so don't be fooled by this. And then there was a war, and I think that's the reason I missed it, that I didn't finalize it in the
you file. Talk about it in the
but I did in the review. I know, I did it in the review session. But I was worried that the review session wasn't mandatory, and then some people would miss it between the cracks. But so now I'm telling you straight on, learn how to do it. I did it enough times in the sense that I gave you the links and I told you solve these questions. But in any case, I'm telling you again, solve these questions. So question number 2 here is somewhat similar to question number 1 on the test. Question number 3 has a lot to do with question number 3 on the test. Together that's 60 points, so you might get 30 out of them. I'm kidding, but it's important to realize sometimes students say, okay, I know how to solve this question, 60 points is enough. But you seldom get all the points and solve everything. Take it into consideration. Don't prepare yourself just for 2 questions, not enough. And the second question on the test, so it was 1 and 3. The second question on the test has to do with the complex numbers, but the catch here, I'm not sure how you will take it, to be honest. It's not super hard, I think, at all, but it uses a complex number in a variety of ways. One section is just complex numbers as find a solution to an equation. Others uses matrices, vector algebra, matrix algebra, vector spaces algebra. So, so you need to study the course in order to solve it, whether it's complex numbers or not. The fourth question, generally, I can put there whatever, but I will tell you for Moed Aleph at least, it's about linear transformation. And I fear this one will be the hardest if you won't prepare for it, because it's a hard subject. It's super important for linear algebra too. So I'm telling you straight on, learn both lectures. I think there were 2 lectures on linear transformation. Learn them both well. They're not easy. And the question in the test, one of the sections is more hard, the other one is easy, but I think both of them might be hard for most of you because you need to understand the language very well to understand why is one of the section easy. I'm not sure you will even figure out which one is the easy one. But so that's the test more or less. And what we'll do now, after I prepared you enough, I think, as to what you should do in order to be prepared for the test. You're welcome to ask me any questions to solve. And if at some point in time you won't have any more questions, then I will start solving questions from this test, or even other tests that contains materials that you don't know, and I can tell which questions are relevant. So I don't give you the links directly, so maybe that will be good. Yeah, so that's what's going on today, and now we're starting. Yes, sir.
Can I ask about part 2 of the complex number question?
What do you mean?
What does it mean? What do you mean when you say it will be a question that has complex numbers in to do with?
Because we learned matrices over fields, and we learned vector spaces over fields. So I can have the field being the complex numbers and ask the same question.
So it will probably just be more of a vectors or vector space or matrix question with complex numbers.
Yes.
A complex number question.
Yeah, in a sense, yes. In a sense, yes. But I think it is a fair description to say it's a complex number question because of a lot of the things that will come very easy to you in real numbers will be a bit harder when you have to do the algebra with complex numbers. And I think that's the main thing there.
Yeah, no, I think why he's asking is like I also looked at past tests with I think it was
with the Morim.
Yeah.
The Morim is a bit different, and I tell you why. With the Morim, the first question of that is from the matriculation test. So it has nothing to do with linear algebra. It's the matriculation test.
So will there be any of these tests that we can actually practice?
No, I think you should practice this because it helps you practice the algebra of complex numbers. That's the point.
But is there any way of preparing for this other section of the complex numbers?
So I think that will be helpful because that's what I'm saying. Because it's not surprising vector space wise or matrix algebra wise. The problem, like I said, is working with the complex numbers. So that prepares you for it. I think it is good to go over it. Okay, even though, but don't prepare that this will be the idea. In the Bagrut, they usually put complex numbers with geometry, and that's not the main purpose here.
Yeah,
Okay.
I did a question on that, which asked me to draw.
Yeah. It's a lot.
Do I
Even
need to do questions like that with geometry?
I think yes, because it's usually not too hard, the geometry, and usually the challenge here again is the complex numbers. So I think it will be helpful, but don't prepare for the question to be as such. It won't be. It will be more linear algebra. One of the sections is quite like this, I think.
Are there also questions? I don't remember seeing any questions on these kind of tests to do with linear transformation.
Yeah, I think that's the main problem. That's why I put linear transformation only in question number 4. So I know that you did not have enough practice on it, but it's fine.
How would you suggest that we do practice
I don't know if practice. I think
or prepare?
yeah. I think solve all the questions I did in the last 2 lectures by yourself, because there were questions there and we find the kernel and the image and the representing matrix and know all the. So I think it will be fine. And the question is also more theoretical. Practice won't help that much. It's more understanding. That's what I asked as well. Because there are questions that require practice in this field, but we didn't do enough practice.
Okay.
Uh,
So are there any questions on these tests that we shouldn't bother going over?
No, and moreover, I think doing question number 4, even though there is not a strict question of this form, will help you as well. Because you find intersection of subspaces, bases of spaces. So I think it's helpful. I think you should be able to solve all these questions, all these tests. I think it will be helpful. Yes.
I found in the test like a group of tests that isn't the one you talked about, but I had it in the things that I should study.
Fine.
And I got a bit mortified, but
Oh, yeah, but okay, know these tests. So this is the linear algebra of math of the use program, which first of all they study. Oops, I wanted to be that. They study 4 hours a week, and you study 3 hours a week. So they
we tried to study 3 hours a week.
yeah, and we had a war. That's also true. But it's a different course. And they're all geniuses. So this is
We are.
much. I didn't say that, but
I did.
but this is a really tough. These are really tough tests. Some of them are some of the questions are solvable. Some of them are not. So that was exactly what I was saying, that I will here today may take some question from this if I know they are relevant.
Stuff like this.
Yeah, so this is more I can do one of them. So do you know exactly which test?
This is String kites 1. So
What's the single? So it's the first one.
Yeah.
You open the first link and then okay, that's enough.
I opened the first link and I was trying to do it before you got
Yes.
here, and I'm like, no.
Okay.
Wait, can I just ask what?
So first of all, that's really interesting because the first question seemed completely up your alley. Look, it's a matrix with parameters over the complex numbers.
What
Right.
made me very confused here is that for it to be solvable and not trying to kill you, you have to change like the first row and the third row, because if not, it goes to
Yeah, but that's something you ought to know, that we like 1 to be up when we do Gauss elimination. That's like elementary stuff that we did study. So question number 1, I'm leaving you for home. I think if you want it, I will do it later. But I think that's good. So it's most questions number 1 on this test, I believe you should be able to solve. The way we write these tests are such that 1 is relatively fair, easy. 2 and 3 are a bit more hard sometimes, and then comes the hard questions. And but it's not just about how hard the questions are. Most of these tests are about linear transformation, and we did not learn as much about linear transformation as they learn. I think that's the main problem.
Stay.
These are the U students. They're 16 and they're starting their bachelor degree. And according to this course and Dida, we admit them to the program. So it's also filtering courses. That's another reason they are relatively challenging. Okay, but not all of the questions are challenging. So question number one here is totally fair in my opinion. Let's look at question number two. No, so this is a specific example. This is the question they have in the homework, they know how to solve, I didn't show it to you, so I won't expect you to know how to do it. You must see, you don't have to, you could solve it by yourself, but you have to know context about these things. For them, it's a question from the homework, so it's easy. For you, you have to figure out how to do it for yourself. So that is not relevant really for you unless you've seen the example.
What do you mean? It's the question of how many
The
copies?
type of saying, the T of V1 is this, T of V2 is this, T of V3 is this. How many linear transformation
copies.
these claims. And the idea is always, and one must know it because it doesn't have to, but you see whether there is a linear dependence between these three. Because I think it was the very last thing I said in the lecture. Let me check for a second. I think it's a theorem I just blurted. I didn't prove. And I think it was the last thing. I'm just making sure. No, that's the test. Second. It wasn't the last, obviously.
Michael.
Maybe it was the last of the previous lecture. I remember I said it in the end of the meeting. Just a second. That's and you might look that this looks a bit similar. The main and this is something I did, but the main difference here is that these three form a basis, and in the question of the test they do not. And just another second, 2 seconds. It's definitely not the end, but did I ever said what I wanted?
Maybe it's the thing you told me to
No,
tell
that's
the next lecturer.
yeah, I don't remember. But no, that's linear spaces, vectors, linear transformation. So I'm not finding it. I'm pretty sure I did say it, but it's not the main thing. The thing is, I will tell you now that when you have a basis for the domain, you can send every element of the basis for wherever you like, and there exists a unique linear transformation that does this, that copies these requirements. So first of all, you need to learn this theorem, and then the catch here is that there is a linear dependence here. And I think I will go over this question just for stuff that I think that will help you. Look, I won't answer what they wanted me to, but I take the basic story and do stuff that does have to do anything to do with you guys. And not just for the test, I mean for the course, for what we learn. So, but for the test as well. And another lecture, no, review session. Okay, so T's ought to be a linear transformation between and polynomial vector spaces up to and including degree 2. And the thing is this. So my question will be, and that you ought to solve, is there a linear dependence between the domain vectors, meaning 1 minus x, 1 minus x squared, and 1 minus 2x plus x squared. So, what, yes,
We put the matrix, it's
Yeah.
we use them as a column vectors.
we take the coefficients and put in a matrix.
Yeah.
So the coefficients are, yeah, I didn't ask you anything about polynomials in the actual test, so it's good for you to, that you translate it immediately. So it's 1, minus 1, 0, and
one.
here it's 1, 0, minus 1, and here it's 1, minus 2, 1. And you do Gauss elimination, and I'll add the first row to the second row, and I'll get here 0, 1, minus 1, and then I will add the second row to the third row, and we get
0 row.
the 0 row is meaningless. You get a column without a pivot. That's what you need to know. I always said that 0 row is meaningless. Remember that? We get in the last column, there is no pivot. In the first two, there exists a pivot. There is, I don't exist. There is a pivot. So the first two vectors are independent, and the last one is unnecessary, irrelevant. I want another word, miutar, but redundant. Yeah, I think that's great. Thank you. Redundant. So now going back to this, and what the point is, we know that y, therefore, 1 minus 2x plus x squared, the third vector, is a linear combination of the first two. So it's a 1 minus x plus b I looked at the last matrix. 1 minus x squared. And why is that relevant? And that's something you ought to know. Therefore, thus, I'll be original, if you apply the linear transformation, you ought to get a times the linear transformation of 1 minus x plus b times the linear transformation of 1 minus x squared. That's the whole point about linear transformation. It's that the linear transformation behaves like multiplication of matrices, and you can do distribution law. Okay, agreed? But you're given in the question t of 1 minus x, right? And you're given in the question what is t of 1 minus x squared. A and B are calculable. We can find them. So the third row here, the third requirement here is first of all redundant, and second of all might be contradictory to the first two. And if there is a contradiction, it's not the case, and I'll tell you why in a second. Because if there is a contradiction, then the answer to the question is fairly simple. There exists no linear transformation such that these three requirements hold together. Okay? And that would have been the case if there weren't a few sections about it in the test. It would be quite weird to ask whether there is a linear transformation. The answer is no, and then another two sections we say there is no. So I know that there is no contradiction by the way the question is written. But in the homework, we gave them a few versions, and in some of them, the answer was there is no such linear transformation because the first two requirements contradict the third. Okay? You wanted to ask something, Thomas?
I was going to ask if we can do the elimination that is left because I don't remember it fully. Because like here you have like a times t of one and then plus b of t of the other one, and then
You mean find a and b? Yeah, we'll do it. Yes, we'll do it. And basically, we already did do it because this is the elimination to be done. But I will show you why is this the elimination to be done. Okay? So let's calculate A and B. And like I said, this kind of question I can put in even section 2. With complex numbers, this is a linear transformation between complex vector spaces, and find out whether the third requirement contradicts the first two. So the general question of how many linear transformation admit these requirements is not something we've learned. But the algebra I'm doing here is something we ought to know. We ought to know even very well, otherwise we won't be able to solve anything about linear transformation. Okay, so let's calculate A and B. That's not linear transformation, that's more coordinates, but that's just vector spaces. So I'm specifically for if it was written in a regular vector form, it will be written, and you can do it, and it will be helpful for us. 1 minus 2, 1 needs to equal to A times 1 minus 1, 0 plus B 1, 0 minus 1. Do you agree about that? I just took the coefficients again. Like I said, in the test, I didn't ask you about polynomials, so everything will, from start, will be in this form. But the trick to solve polynomial is to transform them to this form and then solve them. So don't be obsessed about the translation of the questions to your terms, but the question is to solve for A and B here. Sammy?
Yeah, I just wanted to ask, could you write it as saying that is it just that 1 minus 2x plus x squared is redundant, or is any one of the three vectors redundant?
So it's an important question. I'm glad you asked it because it is in the test as well. When we put the vectors in columns here, what space are we looking for the matrix? The column space. And you ought to know that you take the vectors from every pivot. That's what I was angry with Thomas. You ought to know that you take the pivots from the columns with pivots. That's what you do. So think that you have 15 columns, 5 of them does not have pivot. Doesn't matter which you called redundant or not. You need to know that you take the vectors which have pivots in their columns. That's what you need to know, and that is definitely in the test. That's the third question when I ask for the basis of the column space and the intersection and whatnot. Okay?
Right.
So the direct answer to your question is no, it's not that the third one must be the redundant one, but you don't want to worry about it solving a question. You just take the vectors with pivots and you are sure you got to a set of vectors that spans all of the rest. And that's what you want.
I'm only asking because I solved it a slightly different way.
Yeah.
I
If
got
you-
a different.
Yeah. That's not a problem. When there are three vectors, think of it geometrically. You have three vectors on the same plane. Any one of the two is redundant and can be expressed using the other two, unless two of them are on a straight line. That would be different. So yeah. Okay. So we need to solve here for A and B. Let's write the system of equations. So the first equation is A plus B equals 1. The second equation is minus A equals minus 2. The third equation is A minus B equals 1. So it's not that difficult to solve, to be honest. Right? B is minus 1, A is 2. And does that agree with the first equation? 2 minus 1 is 1, yes. But nevertheless, I will put it in the matrix because it's not always this easy, and I think the best way is the organized way here. So I'll put it in a matrix. And that's one extra column. Delete column. Okay. And you might notice something. And the coefficients of A are 1, minus 1, 0. The coefficients of B are 1, 0, minus 1. And the constants are 1, minus 2, 1. Now I will zoom out to show you this is exactly the matrix we just did the reduction form, Gauss elimination form, I mean. Okay, and it's not a coincidence. We talked about it a bit on the lecture, is that linear dependence is like multiplication of matrices when you put them in columns. That's the main thing here. So I can skip the Gauss elimination to the point we've got to before because it's the very same matrix. Just has the dashed line columns. And so it's 1, 1, 1. Then it's 0, 1, minus 1. And this is 0, 0, 0. And we want the solutions A and B. So if we want the solution, we go to the reduced echelon form. So that's R1 minus R2. And we get we get here 0 and this is 2. And surprise, surprise, A equals 2, B equals minus 1. Okay. So first of all, now we need to remember what are we doing? Like we said, Gauss elimination is the easy part, but what are these A and B's? So A and B came from these equations. I'll put them here. I'll copy them both, to be honest. Not to be honest. That's what I'll do. And that's 2, and that's minus 1. So first of all, we can verify that we did correct calculations. I won't even bother with it. I'm pretty sure I didn't make any mistake in such an easy question. but you can verify and make sure that indeed the third vector is 2 times the first minus the second, okay? Now again, applying the linear transformation, from the left we get t of 1 minus 2x plus x squared, and now we'll go the long way. On the right, we get t of this linear combination. But we know that t of the sum is the sum of the t's, like distribution law, and the scalars come out of the linear transformation. So we get here 2 times t of 1 minus x minus t of 1 minus x squared. That's exactly what I've written above. And now we can make sure whether it's true. If this contradicts the requirements of the question, then no such linear transformation exists. If it does not, then and the rest is not essential for the upcoming test. I won't say it's not essential for linear algebra, to be honest, but I'm not here to teach you extra material that I didn't. I'm preparing you for the test. So if there is no contradiction, you take the base, you add another vector for it to complete the base, and then you can say this extra vector I can send to wherever I like, and it works. But let's just make sure if it contradicts or not. So I'll just copy this equation, and I'll fill out the data from the requirements above. So first of all, A is 2, B is minus 1. And now, what is the first thing? This minus 3 minus 2x plus 3x squared. Minus 3 minus 2x plus 3x squared. Now, t of 1 minus x is minus 1 minus x plus x squared. Minus 1 minus x plus x squared. And finally, 1 minus x squared. It works? Okay. Yeah, it must. Like I told you, otherwise the question does not make sense at all. And okay. And I believe, I don't know how to write believe, but I believe, yes,
I believe.
in Sami, which says it's correct.
Which I'm checked.
Yes.
Oh.
Okay, but if it wasn't, then there is no such linear equation, a linear transformation, and if it's not contradicted, like I said, you don't have to worry about the rest here. Any questions so far?
Couple. We got two linearly independent vectors.
Yeah.
And the third one was dependent. This means we can't make the matrix of the transformation, right? We can't.
No, there is not a unique linear transformation. There is infinite amount of linear transformation because the two vector spaces do not span a base, are not a base for the three-dimensional space. You are missing a requirement. That's the point of the question, which I keep saying. It's not like super important to you guys, but you cannot continue solving without extra data. Let's read the question, by the way. Let's see, I didn't read the next sections. Let's see what they are. Maybe, so find, oh, exactly. So what they're doing now, and that is relevant, they're giving you the third requirement. So basically, say this one is redundant. It follows from the first two. You multiply the first by 2, the second by -1, you add them, you get the third. So the third is redundant, you can strike it out. And then they give you here the third requirement. And giving all three, you can solve the second section. So I will do it. So a bit of the translation is different for you guys, but written the way I write it, you ought to be able to solve it. Okay, so I write it. And so next, I'm rephrasing the question in a way it will be relevant to you. So another question, I will call it, given a linear transformation T from, and let's also do it with R3 and not polynomials to lessen the confusion. So the data is as such. 1 minus 1 0 is sent to -1 -1 1. Next, 1 0 -1 is being set to itself. And lastly, it's here 1 1 -1 is being set to 0 1 0. Okay, so it's the same question basically, but I translated it to your language.
Oh, that's fine.
And we're asking, find t of x, y, z in general. And I just wish to say that that's exactly the question I've shown you before in the lectures. Okay, this is something we did exactly. And I'll remind you how to go about it. The main point here is that if you want to find a general x, y, z, and you are given the values of the images of a base, then what you need to do is find x, y, z and represent it using the base. That's the whole idea of coordinates, which is super important for linear algebra 2 as well. Okay, and also for your test.
How do we know that's the base?
So I'm skipping a few things, right? You need to make sure, and I will tell you how. I won't do it now, but how do you know in general? These are three vectors. You make sure they are independent, and then using a shlishi chinam. And 3 for 2, we said
2 + 1.
2 + 1. I keep forgetting. Yeah, it's a 2 + 1 because it's three vectors and they are independent. So the number of vectors is equal to the dimension and they are independent. By theorem 2 + 1, it means that they are also spanning and form a basis for the vector of test.
Okay.
Okay? Yeah. Okay. So I'll write it in the notes. Okay, no.
If we got a question like this in the test, would we?
Yeah, you will need to do it. Yeah, you will need to do it. Yeah, because I'm translating, so it's not a well thought out question. But they had to do it. Note 1 -1 and 0 1 0 -1 0 1 no 1 1 -1 are three independent vectors. You need to verify this. It's doing another Gauss elimination, right, in columns. And by the 2 + 1 theorem, they form a basis for R cubed. And actually, we will do this verification anyway in a second, because while trying to find the coordinates, we will show that there is always a solution there. That's why it's a base. So we will do Gauss elimination in 2 seconds. That's what I'm saying. Okay, and so let's do it. So we wish to represent the general vector x, y, and z by the base above, which means finding the coordinates. So we say x, y, z is equal a times the first vector plus b times the second vector plus c times the last vectors. And in the language of coordinates, which is not super important in this question, but is important for you guys to know for the test as well, that means if I'll call this set B, that the coordinates of x, y, and z by the base B are the coefficients of the bases, meaning A, B, and C. Okay, so we're looking for the coordinates. We need to do it when we find the representing matrix, which is important, and we need to do it in this question as well. So let's solve it. And what is the system of equations here?
3 by 5.
I'll write it as a system of equations, but when you get the idea, you can skip directly for the matrix as far as I care. So it's A plus B equals X. Sorry, A plus B plus C equals X minus A, second coordinate, minus A
Let's see.
plus B equals Y, and minus B minus C equals Z, and the matrix is matrix 1, 2, 1, 2. Here it's X, Y, Z, and here it's 1, 1, 1, minus 1, 0, 1, 0, minus 1, minus 1. So let's do Gauss elimination to get to the reduced form, R2 plus R1. And
Yeah, can you just scroll it back up from 1 second?
yes.
Scroll even further up once. Let's write something down. Minus stone. That's a minus stone as well. You type it somewhere.
What?
Done type it somewhere.
Where?
Top documents. Oh wait, you took. Never mind, I don't.
No, I took these
Okay,
three
okay,
and
okay,
not
right,
these
right,
three.
okay.
Yeah, because we're working with the domain, not with the
Yes,
range.
okay. My bad.
Okay. So we're here, and so this is 0, 1, this is 2, this is X plus Y. Next, we do R3 plus R2 to get to 0, 1, X plus Y plus Z. And now R2 minus R3 minus 2 times R3, sorry. And then R1 minus R3. And we get This minus 2 times x minus 2 times it's minus x minus 2 minus y, sorry, minus 2z. And here is 0. This minus this is minus y minus z. This is 0. Lastly, yes, R1 minus R2.
6 minus 2y minus this.
Which yields 0 and so x,
X plus Z.
yeah, for x, the y is gone, yeah, x plus z. Okay, so this is a, this is b, this is c, right? The first equation is a times equal x plus z. The second one is b equals that, so I'll copy the, sorry, where is it? I'll copy this and fill out the form. So we found that this equals x plus z minus x minus y minus 2z and x plus y plus z. And ChatGPT 03 has became quite good. I can make sure that I did my calculation right using it.
I'm not paying
03,
enough.
solve for A, B, and C. I just took a screenshot as well. I didn't even copy the text. It's quite well. Yeah. And so A is x plus z, B is minus x minus y minus 2z, and C is x plus y plus z. Yay for us. Okay. So now how does that help us? We go back. We don't go back yet. We write it, sorry. We write it thus x, y, z equals x plus z times the first vector, which is of the base, which is this one, plus minus x minus y minus 2z. This is all a scalar times the second vector, which is 1, 0, minus 1, plus x plus y plus z times the third vector, which is 1, 1, minus 1, 1, 1, minus 1. You're welcome to verify it. For instance, let's do the first coordinate. X plus z is multiplied by 1, that's x plus z. Plus minus x minus y minus 2z, that's minus y minus z. Plus x plus y plus z. Altogether, you're left with x as well, you should. But the point is now apply t, and you get that t of x, y, and z equals x plus z, t of 1 minus 1, 0, plus minus x minus y minus 2z, t of 1, 0, minus 1, plus x plus y plus z times t of 1, 1, minus 1. Okay, and we know all these values because they are given to us here. I'll copy it for a second.
Yeah, same.
Just to make sure that
Yeah, wait, to make sure that we have the last step. So this is this, this, and this. And now let's use the GPT again. And you'll see how. First of all, I will ask for it. No, that I will do myself. Let's simplify it. Okay? Simplify. What is t of x, y, and z? So x plus z minus 1. So it's minus x minus z plus this. So you get minus 2x minus y minus 3z, comma. Now, minus x minus z, this is 0, but this is 1. So it's y. Last, x plus z. So the x is cancelled. No, it's minus. So it's x plus z plus x. So it's 2x and plus y plus 3z. If I didn't make an error. And how will I use the ChatGPT here? I will ask him the entire question. I will ask him the question. And hopefully we'll get the same answer that I just got here.
This seems like an easy question from linear algebra 1, but
Yeah.
the answer to that to solve it.
All right, I need to double check because he knows that part of the question is what I asked him before. So he's checking. Yeah, okay. Look at how easy it is for him. Okay, that's the question. He also gave us the matrix just to be cocky. So it's minus 2x minus y minus 3z plus y 2x plus y plus 3z. Yeah, exactly. Okay, and the way he solved it, look at it. It's the very way we did it. He found the coordinates. Doesn't explain the way, but he finds the coordinates. Then he applied t, he plugs it in, and he solved the question. Okay? Yes, Thomas.
And the way to make the matrix representation of the function, we just grab this the values, the coefficients of these vectors, and just put them in columns.
So it depends on the base. That's according to the standard base. Yes.
This is according to the standard base.
Yeah, because the way to find the representing matrix is to apply t to the vectors of the basis, and that takes the coordinates according to the image basis.
Yeah, but didn't you do that just now by applying t to the?
Wait, so it depends on which, so it really depends. You know, if you want according to this base, you will get a different answer. It's not just putting these coefficients in column, something else. It's
Okay.
putting, actually that's relatively trivial, it's putting these in columns. Because these are the images, but that's if you take the standard base for the image and this base for the domain. Okay, so it really depends on which bases do you take. Okay. So next question.
Get the kernel and the image.
We can, I'm not sure it's super important now. Okay, that's exactly what I was about to ask. Do you wish to go further into linear transformation or go over one of the subjects? because Tomas and Sammy are asking the question, and they went over everything. But it's important that we make sure the rest of the 90 points are for us as well. So do you wish to go further into linear transformation, which, like I said, are important for the test, but that's just one subject, or go over subjects from the first 3 questions?
I think that we should probably at least one intersection of bases.
No basis of vector spaces.
Yeah.
Okay, great question. Okay, so let's find a question here, which we are asked to find a basis for intersections.
Should we be practicing the exam using these exams rather than the other ones?
When I'm here to
Tell us what to ignore.
so yes, but at home probably not.
That's quite frustrating. Are there not like past exam questions that you've written?
Usually
So
that's.
that's what I gave you, but that's what I gave you. So this is the extra.
Oh, from our course, I mean.
No,
No, this is the first time I'm doing this course for a computer. But like I said, I gave you very good practice for 1, 2, and 3, and for the theoretical question by a matter of principles, I'm not doing practice because the point of the last question is to make sure you study actually the material and not just doing practice questions. So I'm not feeling too bad about this, but this is you can use it, but it's harder.
And
So after you've finished everything else, go for it. Learn it. It will also help you. If not for this test, it will hugely help you for linear algebra too. It's important, but I'm also trying to be fair.
Kernels and the other thing, they could possibly be an exam.
What?
kernel and image of the.
Yeah. I just didn't want to do all day only linear transformation and then have you guys not solve the first 3 questions, which are the one you're supposed to do. It's not that it's irrelevant, right? There even something to do with the kernel in the test, to be honest. It is important. Yes.
Except for a very particular like case of transformation when we get like something goes to 0 or whatever. We have to find the matrix and then get the null space and the column space.
Yeah, that's one way to go about it. Here, I think it would be the best way to go about it. Yes. Okay. So in this test, I'm not finding intersection. Let's go for another test.
It's 613 probably, but
I'm opening a few.
Such hard.
no, not this one. I mean chemistry. Chemistry is usually the one.
It's even too easy, this question number 1.
Shouldn't
That's definitely up your alley.
doesn't
Solve
it
by
be
yourself. I want you to solve this one. And also, you have a recording of this session. You can go over it and you know what? I'll make things even easier for you. I'll copy it into the page and tell you at the end, solve these questions. Okay, do something else. No,
just
because then you won't find the solutions.
I sent the like this link
Yeah,
and it has the solutions next to it, but like
but yeah, I'm just figuring out how lazy you are to be able to go to the link and open it and find the question. But I'll write it. Tomas will find it, and then you guys will. Maybe you will do it yourself.
sorry, I don't know if I'm misremembering, but the answer to the intersection between the base of the null space and the column space is 0 always, no?
The column space, the null space, no, and the row space.
And the row space.
Yeah, because the null space is perpendicular to the row space.
So not connected to the conflict.
No, so it has nothing to do with the conflict. Okay, question 1 here. Let's. I've seen another one. I'll write to you as well. And question 1 here. Question 1 in here. So that will give you more practice. The solutions are next to them. If you can't find it by yourself. By the way, you can write sol at the end. And it doesn't work. I'm surprised as to why did it not work. Sol. Why did it not work? Ah, no, it doesn't work. Okay, it's the name of the file, but it's in a complete different directory. The way the MediaWiki works is if you have too many files in the same directory, a lot of the operation systems collapse. So you put the files in different random directories, so you're not able to go about it this way. Okay, fine. So question number 1, I'm not solving to you, solve yourself. Question number 2, prove this is a base is up your alley, and this is a bit harder, but you can solve it. I won't copy it, but you can solve it too as well. But wait, I'm looking for a intersection. You said intersection, I'm looking for it. But the less, oh, I think this is fine. Oh, this is a great one. Okay.
How did you prove it was a span? Just by Gauss elimination and saying you can have like.
What do you mean it's a span?
Like you have 3 vectors.
I said I proved they are independent and they span the entire vector space because of the 2 plus 1. They are independent and there are 3. So that's 2 out of 3 requirements. That's why they span everything. Okay. So let's solve this question here. We have a matrix A. We have the vector space U, and we have the vector space W. We ought to prove that U is a subspace of our 4. We ought to prove that we are to find bases for U and W and find bases for the intersection. So that's a great question because it's a bit tougher than question number 3 on your test, but it's still the same material, so I think it's good. So first of all, U has a neat trick to it. How do you prove something is a subspace? If you remember, you need to make sure there is the sum 0 is there, the sum of vectors remains there, and the multiplying by a constant. But here there is a neat trick. Note. So for section A, note that AV equals 2V
It's a linear transformation.
if and only if AV minus 2V
Subspace.
equals 0. Okay. Who can tell me the next step?
The null space of. I mean, you have to say if the null space exists. I thought.
The next step.
Is factorizing it out.
So I want to take V out, right? How do I do that?
It's just distribution.
Yeah, no, obviously, but what I'm asking is what is written here? After I took V out using distribution, you are correct.
Very nice.
So what are we left with here?
A minus 2I.
Exactly. Okay. So sometimes students just leave 2 here. I'll do it for a second. That is nonsense. Why? What is A? A matrix, and 2 is a scalar. That doesn't make any sense. You cannot do operation between them. But A minus 2I does make sense. But who promises me that it works? Because when I use the distribution law, A times V is AV. And what is 2 times I times V? What is IV? Simply V, because I is the unit matrix. Okay, so U is basically the null space of A minus 2i, and therefore is a subspace. Because we know in general, the null space is a subspace.
Yeah, when I read the solutions for the last lesson we're looking at, it said exactly that. I don't
Yeah.
remember
Yeah.
us particularly talking about it much. Like,
There is a whole question about the subspaces of matrix. They are subspaces. So we didn't talk about it much because you don't need to talk about it much. We said these are subspaces, and now you need to know it, you see? And yeah, so there are things we said, and there are things we said 1,000 times, and I'm aware of that. We did say it, right? And in their tests, we use it often. So yeah, students that prepare for that test are more ready for that test. But I think you will prefer the test that I have for you
yeah, I would be surprised.
than more practice tests to a horrible one. You wish an easier test and with less practice. So
We can say this because you like take B to the other side and it disappears, or
why do we mean this? Well, I've had one, two, three claims here. First of all, is that this equation is equivalent to that equation, and guess you're
Yeah.
fine with that. Then this equation is equivalent to this equation, right?
Sure.
And then I'm saying it's equivalent to saying the null space. Do you agree
Wait,
about that as well?
Wait, let's go back. B is a coefficient in this case, not or a vector.
Vector.
Okay, sure.
It's not a scalar, right? It's A times V.
Yeah.
Here.
Yeah.
V is from R4, AV equals 2V.
Okay.
Okay, so I did algebra manipulation to make sure that to find out that it's actually the null space of this matrix. It's all the vectors that once multiplied by this matrix, you get 0. And then, like I said, in general, the null space of a matrix is always a subspace.
Mhm.
I might have proven it, and I might have even told you it's homework to prove it because it's really, really easy. Okay, but we know it's a subspace. We find basis to it all the time, right?
Yeah.
So it is
No.
a subspace.
No, my question was where does the vector go in this case?
What?
The vector when you go from a minus 2i times b
Because the
equals-
definite. Correct me if I didn't understand you correctly, but the definition of the null space of B,
I is 0.
no, the definition is all the vectors such that BV is 0. That's the definition of a null space. So when I'm saying the null space of this matrix, I'm basically saying all the it's like a kernel. It's all the vectors that once you multiply, you get 0. All this data is just encapsulated in the letter N when I say the null space of the matrix. Okay? So yeah. Okay. Okay, so it's a space. So the first question was prove that U is a subspace of R to the 4, and we did it. Okay, next we need to find a basis for U and W. So U is a null space of a matrix. We know how to find the basis for a null space of a matrix, and I will do it. How about W? Is this a space of a matrix? Which matrix? But which one? If we put these vectors in columns, then that's the column space of this matrix. So it's a lot about doing translation into matrices and then using Gauss elimination. That's why I chose this question. So for you in the test, I'm directly asking for the column space, row space, null space of a given matrix. But this question just needed some algebra to figure out it's the same thing. This is the first one is a null space of a matrix, and the second one is a column space of some matrix. Different matrices, but basically the same thing. And how can you practice such question? These are the question number 3, I think, in the Morin test, in the teacher's tests. Okay, so let's go about it. Section B. We'll start with you. B. We will start with U, that is the null space of A minus 2I. And just a quick word about, again, something which in this test, but it necessary in general, is that the translation, if you didn't solve, if you didn't figure out this neat trick in section A, then you will also have a problem in section B, right? So that's what makes this test a bit harder, because if you're not completely on the material and know how to speak the language, it makes everything that much harder, because now how do I find a base if I'm not knowing this is a null space, okay? So
We've been given it.
what?
No.
We've been
Yeah,
Ah,
of
right.
course.
Oops.
Okay, of course.
Both.
Otherwise, it's not solvable. Find a solution for a general equation. I'm not giving you the equation. That's something that computer science test will do, not mathematicians. Okay, yeah. Okay, we will start with finding that. So how do we do it? So first,
Right.
we'll calculate A minus 2I, which is 16 numbers. 1, 2, 3, 1, 2, 3. Okay. So
Copy paste and was easier.
minus
you can't.
2. What?
You can copy paste. You can ask ChatGPT to
Yeah.
translate it.
Oh, yeah. 1. By the way, I also tried, not in your case, but asking ChatGPT to design a whole test. That it still does not do well. And I gave him the link in MathWiki and told you read this test. It was so funny because like after 3 seconds, I said, okay, I read them. And then he gave me a test 2 seconds later. But what he basically did is choose random question from each test, change the numbers up a bit and gave it. It wasn't original in that sense of sensing the whole thing, but it did say these are the subject of question number 2 and chose one of them. It is very impressive, but still not human yet. Okay.
Maybe we should recommend Marina for test.
Yeah. I don't think you need to. Probably she already did it.
I can't confirm nor deny.
Yes. I'm not sure it's confusing. Even ChatGPT says it's a great test. 3 minus 1.
Why did you do the? Did you do it in advance? The subtraction because
Yes. Yeah, it's already subtracted. I did it in but I subtracted I and not 2I.
yeah.
Okay, so I need to subtract 2 from the diagonal. So minus 1 minus 2 is minus 3. This is 0. This is 1. And minus
0.
minus 3, 1 minus 1. Minus 3, 1 minus 1, 0. Okay. So now let's do Gauss elimination. And yes. And in order to save time, I will do a lot in my head. I won't write the operation I'm doing. So this plus the first is 0, 0, 0, 1. And this minus the 0's third
Now
plus the third, I mean 2. And this is 0, great. And now this is 1. This is minus 1, so this is 0. So this is 0, and this is 0. So this is 3 and this is 1. So this is 1 and this is the third. Yeah,
I didn't
Okay.
follow, but,
Wait,
you don't need to do it at home. It's not really important.
can you go back up for a sec?
You can ask ChatGPT to give you the steps.
I don't pay enough.
That's catch 22. I don't have enough money
I think you
to
got that
to
right.
get the ability to get a job. Yes.
What was go back up to 8 for sec? You did -2 on the
Yes, minus 2i, not minus 2 everything.
yeah minus 2i. So in the second value, the second
Is
that,
ought to be
minus
0,
2.
right?
Yeah, but it is.
You are correct.
Yeah.
So,
Minus.
okay, just a second.
You end up with it's
I think what I'm doing is extremely stupid. Never. Yeah. Yes, that was stupid. Okay, I'll do it again. Fine. And so yeah, this is 0, 0, 0, 2, and then 0. And this plus this 0. Oh, that's a huge 0. 0, 0, 0, something that becomes 0. This is 1. This is 0. So this is 3 minus 1. 1. So this is 1 minus a third and a third. Yes. Okay. Okay. So we have two pivots here, one on the first column and one on the fourth column. If we were asked about the column space, we'll take the first and the third. Wow, it's so easy to see it now when I'm thinking about it. Look at it. The second is the minus of the third, and the first is 3 times the third, right?
Yeah.
All first three columns are redundant. Now looking at it, it's quite clear. But in any case, it's not what we're looking for, because we're not looking for the column space of this matrix. It's not a question. We are asking about the null space of this matrix. So it's not really relevant. But we do need to look at the pivots, because in the columns where there are no pivots, these are the free variables. So the second variable, call it x2, is t. The third variable, call it x3, is s. So what is x1? X1 is 3t, t over 3, minus s over 3. Yes. Okay, and what is x4?
1.
No,
No, it's -1.
No.
x1.
no,
it's x2.
no.
0.
0, guys. The second equation is 0x1 plus 0x2 plus 0x3 plus 1x4. 1 is the coefficient of x4 equals, and because it's a null space, it's the homogeneous system, equals 0. So x4 equals 0. Okay? So these are like the stuff you need to make sure that won't happen to you, because this is what I say 60 becomes into 30 quite fast. So you have, and these are the stuff that using practice we get better at, and for this you have enough practice available. TS0. Okay, so this is t times a third 1, 0, 0 plus s times minus a third 0, 1, 0. So u is the span of these two vectors. I can multiply them by 3. and say 3, 1, 0, 0,
Isn't it 3-3?
and
1, 3. Not
What?
1.
Isn't it 3-3?
no, this is a third. I multiply the vector by 3, so it's the same direction. Ah, no,
1,
it's
3.
1, 3.
So
1, 3.
minus
Sorry.
1.
Minus 1, 0, 3, 0.
Yes.
So the last step you didn't have to do, but it's easier on the eye, because if you take a base and you multiply each vector of the space by some scalar different than 0, it remains a base for obvious geometrical reasons, at least. Algebraically, it's not that hard as well, but it's not important. If you wrote these two vectors, it would have made sense, right? But it's easier for me, so I wrote it this way. Okay, so we have the basis for U. This, without the word span, once I say span, it's the whole vector space, but just the set, that is the basis. And what is the dimension of U?
So,
Yes, the dimension of U is 2, because there are two vectors, two directions in the basis of the vector space.
Yeah.
Okay, so this is U. Now we wish to do the same for W, and like I said, we translate it into, it's like in computer science, it's like using either classes or a library. If we put it, I think object-oriented programming actually is quite mathematical concept. Reminds me of fields, right? We say this is the interface, this is the properties that needs to hold, and once you got it, once you put your problem within a certain design pattern, then you solve it automatically because you know how to use it. You use this library. So we had a W here, which is a span. If we understand it's the column space of a matrix, then we are able to solve it. And in U, we found out it's a null space of a matrix, and that's why we were able to solve it easily.
if you want, I mean, I'm looking at it and in this case, I don't know if in the test I require to do the elimination, or I can just say 2 of the first one minus the second one is the third one.
Yeah, but it's first of all, it's not a scalable scale. That's one. And second of all, you must also say, okay, your reasoning is why one vector is redundant. Why isn't there any other redundant vector? So that is also something you need to address. That's why I think the best thing is to use the library. And what you're trying to do is like most annoying programmers. I will do it myself better than what I did. It's really quite the same thing.
It's RSA.
Yes, yes. Let's yeah. Yes. I had a friend once who worked in a place, wasn't very professional, the place, that they told her to program encryption system for the you never program an encryption system yourself. Never ever. That's just a way to make sure your company
Gets
is
hacked.
not safe. Okay. So 111. We will create a matrix such that W is the column space of that matrix. I'll call it B. And B is simply matrix Schroeder. Yes. Yes. 1 1 1 1 1. That's easy. 0 7 10 1. 0 7 10 1. 2 minus 5 minus 8 1. 2 minus 5 minus 8 1. Just making sure I really get that. Okay, so we do a Gauss elimination. Again, I will do it quickly. So that's 0 minus 7, 0 0 and 0, 0, 0. 1 minus 1. There is no pivot in the third. There is no pivot in the third column. Therefore, the first two original columns are form the basis, meaning W is the span of 1, 1, 1, and 0, 7, 10, 1. Okay, so that's the answer to question 2, and the dimension of W is 2. Okay. By the way, do you need a break at some point? A break point?
I'd like to go to the toilet.
Yes. So do you want?
10 minutes.
You can always go to the. But do you want a break?
I can do it in like 2.
Yeah, but
Let's take 10.
that's completely. Let's take 10. Yeah. Okay. So let's
You can
take.
take 2, it's fine.
Let's take 12 until 4:45. You can take your time, Sammy. You can use a slow flow.
I know, I
What do you mean? Do I ask
Do you-
about it in the
No,
test?
do you use it to solve questions? Because like
Yeah. Theoretical question, proof.
mm,
You know, when you prove claims, you never, hardly ever use once when I started to be a TA, a teacher assistant, then I've shown that calculating the limit of the n root of n, proving it one, you actually use the definition, but now I do it with the ratio test. So I can't think of a single calculation problem you do with the limit. But in the theoretical question, when you prove theorem, then yeah, sometimes you use the definition of a limit.
our test only has theoretical questions as the last one, right?
I don't remember what I told you. Is it written in the? No, yeah, but I think so. Wait, limits, series.
Function.
No, I said two theoretical questions, but one of them is it's semi-theoretical. It's like doing an analysis of function. Semi-theoretical. Yeah.
Yes.
Okay, yalla. Let's yalla.
Let's
Like what is minus 6 squared x?
You might be right. I make sure I'm not. No, the derivative of sine is cosine, not minus cosine. Oh, the derivative. You might have written the formula wrong. Yeah, it's f prime g. I'm not sure with g and h. In any case,
Wait, just tell me an f and g then.
so it's if it's f over g, it's f prime g minus g prime f over g squared.
Yes, I always do this. I always mix it up.
Mm.
Always.
Anyway.
It's a good thing you don't have a test about the subject next week.
Mm.
No, yeah.
Suspicious. Anyway, can I try to solve the
Yes. Okay, so the third part of this question is to find the intersection of the two subspaces. There are a few ways about it. Thomas will guide the way. And
We'll try.
yes.
I for sure will try.
Yeah.
So I mean, you could either start with the algebra or start directly with a matrix. Let's start with algebra because that's what we do. So you say that the sum of the like x equals one minus one or a minus
Yeah,
b.
so I'll put it into frame. First thing, see, now we wish to find a basis for the intersection.
Mm.
And for that,
We prefer the algebra.
we will transform the spaces, subspaces, into their algebraic form. So now just a small note here. U was given algebraically from the get-go. So theoretically, we can use the original this matrix and say these are the four equations that will save us from, you can have it, Sammy, if you write on boards. It's a gift from me to you. All the times I made fun of you during class.
It's also dying from.
Yes.
I still mind from computer science. So
Yes.
Yeah.
But the problem is that it's four equations, and if we'll do the translation now, we'll get only two equations. It's not that big of an earthquake, but we'll do it anyway. And I also want you to practice being able to transform. So how do we transform? We are asked, we know that a vector is within U if it's a linear combination of these two vectors. So I'm writing x, y, z, w is within U if and only if there exists A and B such that X, Y, Z, W equals A times the first vector plus B times the second vector. And that's what you said.
Yeah.
And therefore we get to the linear system of equations. A minus B is X. And 3A equals Y.
3B equals Z,
3B equals Z.
and W equals 0.
And W equals 0. And our ask is what we're asking is we're solving for A and B. We are solving for A and B and asking when a solution exists. Not what is the solution. We don't care here about A and B. These are the coefficients from before. We don't care about the coefficients. We just want to know when they exist. Because if there exists A and B, then X, Y, Z, W is in U. Okay? So I'm going over it slowly, I hope. But that's the method we always do. The only thing that changes is the vectors in the span. Their number, the number of vectors, the size of the vectors, but it doesn't really matter. You always do the basic same process in order to get to the algebraic form. Yes, Thomas, what is next?
I was going to ask, in theory here, you don't really need to have it in a echelon form, but it's better just to do it because it's the same thing we do always, right?
In what form?
Now you put it in a matrix, obviously. So it's a
Always do it. Always do it. Why do you feel that you don't need a matrix here?
no, you need a matrix. What I'm saying is you don't when you reduce it, it doesn't need to be the normal echelon form because you only are trying to find the
Yeah. I didn't normal internal form. You mean the reduced echelon?
yeah, you don't have to do it
Yeah, I didn't know this expression. Okay, canonic. Yes, you don't need to do it reduced echelon, just echelon. Yes.
No, I mean, sure. Let's first do the matrix and then I
So let's put it in a matrix.
So 1 minus 1.
Matrix. We have 4 is that A, B, comma that. Okay. So dash dash dash. And here we have X, Y, Z, W.
And you have 1 minus 1.
I think that was confusing to me because I wrote all of them on the right side and you said W equals 0, but X, Y, Z, W are parameters. They're not variables we solve for. And here we have 1, minus 1, 3, 0, 0, 3, 0, 0. And that stems from putting the vectors here in columns. That's the shorthand. And if you wish to go from here directly to here, that's even in general. If you want to go to the algebraic form, you can skip directly from here to here. The problem with this is sometimes students don't remember why they did it and what they're supposed to do. So now let's have it reduce it. So I'll
You can change to them now.
no, I'll okay. I'll multiply the first row by 3. It's a bit unorthodox, but it will leave me without fractions. Okay, now I can do R1 minus R2 and then R1 plus R3,
Yeah.
and then we get zero, well, 0, 0, and here 3x minus y plus z. Okay, and we need to replace the rows such that we'll get three, oh, 3, 0, y, 0, 3, z, 0, 0, 3x minus y plus z.
Yeah, this is what I meant. You could have left it as it was and it wouldn't change really out and like that.
You need to make sure you are able to get it into an echelon form, right? Read it here, you can do it in your head and say this is almost an echelon form, yeah. Because that's only the claim that the 0 rows has to be in the bottom, which is not very interesting.
Yeah. So now we get that 3x minus y plus z equals 0.
So, yeah, so in order for it to be a solution, so a solution exists if and only if 3x minus y plus z equals 0 and w equals 0, because then you don't have a contradiction line and you do have an echelon form, meaning a solution exists. Okay, so altogether what we've proven here is that u equals to all of the vectors x, y, z, w such that 3x minus y plus z equals 0 and w equals 0. Now it might interest you to know that this is the null space of which matrix? This is the null space of 3 minus 1, 1, 0, 0, 0, 0, 1. Is that surprising in any case?
It shouldn't be.
This is exactly the original matrix A minus 2i. Here, that's that. Right? That's why I say it was redundant. You could have used that directly because it was already in algebraic form. I still even suggest to do the long route because then you won't make you're less likely to make a mistake. But it was unnecessary. Okay. Now we do the same thing for W. And the point being here is that if we want to find the intersection, we will have to find all the vectors that admits these equations and also the other equations. Then you have a linear system of equations which will solve and find the intersection. So we'll do the same for W. And for W, I'll do it quickly, meaning without explanations, just the algebra. We will do the same for W without the extra steps. Explanation. On the silence, I see there are no Rick and Morty fans here. No? No.
I don't remember the reference. It's been a long time. Anyway,
Yes. So
4x4 matrix.
we take Yeah, you're right. This is X, Y, Z, W, and this is 1, 1, 1, 1, 0, 7, 10, 1, and now R2 minus R1, R3 minus R1, R4 minus R1, and we get 0, 0, 0, y minus x, z minus x, and w minus x. Next two operations will be R2 minus 7 R4 and R3 minus 10 R4. Always going for the 1, like you said before. If I see a 1, that's the one I use to eliminate the others. If there are parameters here, it's even more important. If there are complex numbers, it's more important. It's a good thing to know.
And this will give you a different solution, right? Depending on what you do.
Might. I think because this, yes, it might. Because it's the intersection of two planes, so there are many different two planes that go through the same line. So there are infinite number of possibilities, that's true. So that's 7 minus, so y minus x minus 7 that, so and that's plus, so it's
Plus 6.
6x plus y, that remains a y minus 7w. And here we get 9x plus z minus 10w. So we figure out, and here I'm skipping the change of the order, the reordering of the rows. We found out that w is all of the vectors x, y, and z, and w, sorry, such that 6x plus y minus 7w equals 0, and also 9x plus z minus 10w equals 0. And usually in class, I would put it in GeoGebra and show you and say, "Ooh, look at this." But I can't do it now. Why can't I do it in GeoGebra?
Because it's 4-dimensional.
It's 4-dimensional, yeah. So I will use ChatGPT later to solve the question, make sure I didn't do any mistakes.
So the first one you can, because that will equal 0 now.
No,
I mean, you don't need to.
yeah, but it's not exactly accurate. Okay, so now what is U intersection with W? It's
So
all the x, y, z, w such that all four equations hold, right? Because the first two equations need to hold in order for it to be in U. And the second set of equations, a pair of equations needs to hold because you wish to be in W. And if all of these equations hold, then you're in the intersection. So from the algebraic form of the two subspaces, you get the algebraic form of the intersection immediately. And now you have a null space of a matrix, basically. That's the null space of 4x4 matrix, which is 3 minus 1 1 0 0 0 0 1, then 6 1 0 minus 7 9 0 1 minus 10. Let's solve it. So R3 minus 2 times R1, R4 minus 3 times R1, and we get to this is 0 minus 2, so that's 3 minus 2 and
-7.
right. So later I will nullify the -7 and -10 because it's easy. They are nullified by this one here. I'll do it later. And this is 0, this is 3, this is -2. How surprising. And this is I don't care about, but it's -10. So next I will do above R4 minus R3. Okay. And it's jumping up and down. Okay. I need to restart the computer. And I need to log on to the Zoom so it won't quit. It happened to me one time. One of the students, I think, which I made admin, closed the session and the YouTube recording stopped. Okay. And for whoever is watching the recording, we'll be back in a few. Okay. And there's my video panel. So here on the row. Okay. So R4 minus R3, that was the next operation to be held, applied. And so that's 0, 0. And next we do R3 plus 7R2. And R4 plus 10R2. That nullifies the 7 and the 10. And why is the 7 and the 10 so unimportant? Because X4 is W, yeah, W is 0, basically, yes. And just finally the reordering. I'll write it. I don't like to write because it's hard for me to write left, right arrow. But R2, left, right arrow. Okay, with R3. And we get our final form. No, I forgot what I was going to do and what I was set out to do. That is not the final form, right? Because what are we trying to get here?
The equations to get
The solutions. We need to find the solutions to the system of equations because the intersections are the solutions. So we need to get to the reduced echelon form. So that is not even my final form. So it goes well with the mean. Okay, so we need these to be 1 and that to be cancelled. So
you can do the third of
and
the second
third are 1 and the third are 2 and get one minus the third and 1 go ahead third minus 2/3 and last but not least R1 plus a third of R2, which brings us to this is 0. This is plus a third of this. So it's 2/9 and this is 3/9. So 1/9. Yeah. Okay. And now we'll write z equal p. That's the free variable since there is no pivot on the third column. X is minus 9p. Y is 2/3 of a t. Z is t, we said, and W is 0. So the intersection altogether is all of the vectors of the form minus 9p, 2/3 of a t and a 0, is such that t is a real number, and altogether that's the span of, I'll multiply by 9. So I'll get -1 6 9 0.
nice.
Okay. And now let's make sure it's true.
Just one question. You put in the algebraic form and you get out the geometric form in this case?
It's a good question. Why didn't we stop at the algebraic form? Because I told you, like in complex numbers, that the geometric form is just as good as the algebraic form. Actually, in complex number, people usually prefer the algebraic form. So why didn't we just stop at the minute we got to the algebraic form? Someone asked me, what is the intersection? That is the intersection. That's the algebraic form of the intersection. The hint is in the small letters, the hidden print, whatever.
It's an ask for the basis.
Yeah, exactly. We were asked for the basis. And the basis, almost by definition, is the geometric form. Because the basis is a set that spans the entire vector space. So we were basically asked for a geometric form. That's why we did it. And we know the dimension as well. I didn't write it. I'll write it before I'm going back to GPT. What's the dimension? 1, exactly. It's a line, but it's a line within the 4-dimensional space. That's why I can't show you it. But I can ask GPT for the following. Solve Gimel. I'll tell him in Hebrew.
But answer it in English.
Yes, yeah, because the math is upside down in Hebrew. It's so, and save email, בבקשה, ותכתוב את התשובה באנגלית. Let's see. He has to go all the way.
Back.
Pivot in columns 0 and 3. It's weird. No, it's 0 count, yeah. 0 count because it was 1 and 4. Do you see? You wrote the correct answer. And -1690 exactly. Within the analyzing, it might give me the answer. Can you see? Let's see how we did. So first of all, recall that U is the kernel of A minus 2I. Recall from where? When did you say that? But it's true. And these are the vectors. A general vector is this, imposing the condition. I'm trying to see if it's the same thing.
Oh,
I'm not sure if it's the same way we did it, to be honest. But in any case, he got to the same final answer.
That's what working out compared to what we did.
Do you think that's the reason? A lot of times it doesn't show its calculation. So let's read it and see if it was a quicker way than we did it. And I doubt it, but it could be. So first of all, in one sentence, he did something I explained a lot, that U is the null space of A minus 2I, fine. W is this space, fine. Now reducing A minus TY, no, it did exactly the same thing, Sammy. Look, he went for the algebra, at least in one, he went for the algebraic equation. So we did that.
He's just not showing the work.
Yeah, I think so. Let's see what it does in 2. That's what I didn't follow, so I'll try to read now. A vector is of the type alpha W1, beta W2, and lambda W3. That's true. Imposing the two conditions from U, it does it in a bit of a different way. And it's not, I think it's not mathematically sound because he's imposing the conditions from 1 over the geometric form of the 2. That's fine. And he reduces, he says this is the only answer possible. But I think it doesn't prove that this answer actually is possible. That's one thing. And if he had a few answers here possible, he might have been in a heap of trouble. So I don't love this way. But I'm not sure it's actually even saves time. But it is different than what I did. That's definitely true. And he did find the correct solution. So kudos to ChatGPT.
I for one welcome our AI overlords.
Yes.
I'm sure I've heard you sort of exact line previously.
I am too sure. Yeah, that's a repetition of code. Okay. So that question was that. That was fun. Let's do something else. Do you have any subjects you wish to go over?
So we did transformations, we did
Yeah, we did.
space and
We did 3, so we have the complex numbers and the elimination of matrices with parameters.
I hate that. Why do we do that?
because
Let-
it's
let-
an
let the
it's an
computer do
easy
it.
way. That's true, but you wish the computer can do everything as you've just seen, but you wish to get the points yourself. So I can give you things that will be even hard for the computer to solve. Are you sure that's what you want the test to be? Yeah, it is silly, but it's a way to give you easy points. I think that's for your sake. But maybe it's not. Do we need to solve such a question? What do you think? Maybe we'll
Sure.
do bet here.
I think sure, probably.
I think we'll do bet here, and I'll. I go. And I'll translate it to vector, so you won't be scared of the polynomials. Yeah, I think that's a good question. I think that's fine. Okay. So no, I won't copy it. I will write it and I'll do the translation. So question as follows. T is a linear transformation from r squared to r squared, meaning r cubed to r cubed. And B is a basis, which is 1, 2, 0, 2, 3, 4, 1, 0, -1. Okay. And the matrix of A, the represented matrix of A from B to B is to be or not to be. And is 0, A plus 1, A squared plus 2, 4A plus 2, 1, A minus 2, A plus 1. Okay. And the question is find basis and dimension for char T and image T for every value of the parameter A. So that's a neat question in the sense that it goes over 3 questions of our test. First of all, you need to be able to reduce the matrix and know its rank for every value of A. We need to find the rank of the matrix for every value of A. That's one thing. The second thing, we need to find basis for the null space of the matrix. Why? What does the null space represent?
The kernel,
The kernel. And the image, what is that?
the column space.
And the column space of the matrix. So that's like question number 3, right? And lastly, we need to translate the coordinates to the actual vectors. So that's linear transformation slash coordinates. It's coordinates, right? So that's like the last subject. It's not exactly 4. It could be like in complex number as well in 2. But it's the subject of coordinates, and we learned it under linear transformation.
How do we need, how do we find the basis for the null space and the column space with A?
Yes,
Like it's for
with A. Everything is with A.
Okay.
Obviously, there is a parameter in the question. The answer will be using the parameter. So I've told you how to do it in 3 sections, and we'll go after each of them now. So let's start with the first. First thing is first. That's
what first means
tautology, I think.
tautology.
How do I write taut?
Tautology, I think.
Tautology?
I think so.
Tau, like this?
No, we don't know instead of a second unit.
Tautology.
No, T-A-U-T, sorry.
Tau,
And that's a no instead of an A.
Yeah, it's not pronounced tautology.
tautology. Oh, right. I think. The reason I'm not sure it's a tautology is because there might not exist a first thing, and that makes for the empty set it might be a problem. Depends on how do you formulate. Okay, that was a detour. Yes, it was too long. And just a second. Okay. So we reduce, and the first thing we'll do is R1 left, right, arrow, R3, because we want the 1 up top. So this is 1, A minus 2, A plus 1, and the last one is 0, A plus 1, and A. Next, we do R2 minus A, R1. This works for every value of A, so it's great. So that's 0. That cancels out, and we are left with 2 plus 2A, right? And here we have 4A minus A, that's 3A, plus 2 and minus A squared. Yuck. Okay, now we'll do R2 minus 2 times R3. Do you notice it?
Okay.
Otherwise, what would we have done? We would have tried to cancel the A from one of them, so we'll get just a number which we can make into 1, and then we can cancel it out. And that's pretty much the way you do it with complex numbers as well, which you should know for the test. You cancel out the I, and then you get something easier. Sometimes it's not the only way, but it's a good way. So and we'll get here 0, and here you'll get simply A, and last thing, switch left, right arrow, and between the second and the third row. I'll get A plus. It's the longest one, so I'll copy it. A plus 1, 0.
Still pretty old.
You won't get, now I see it, you won't get A in your final answers. You'll see in a why. So first of all, we need to make sure or calculate when does these two pivot contenders, sorry, are zero or not. So a squared minus a minus 2 equals 0. That's a minus 2 times a minus 1. Okay, so for a, which is different than
Isn't a minus 2 a plus 1?
you're correct. Yeah. So for a different than minus 1 or 2, the matrix is of rank what? 3. Therefore, it is invertible. Yes, and T is invertible. Oh, nay. And T is invertible. And therefore,
The kernel is 0.
the kernel T is 0 and is 0 dimension. And image T is, because it's surjective, it's all of R3, not B, all of R3.
Yeah.
So the basis will be the empty set and the standard base respectively. That's why we won't need A, because for either, if A is not minus 1 and it's not 2, the matrix is invertible, the function is invertible, and invertible function has is 1-to-1, meaning the kernel is 0, and it's surjective, meaning that the image is the entire range. So I could choose any basis for R3 that I would like. I could have chosen B as well, but I wanted to emphasize that I could choose any basis for R3 that I like, even the standard one. Okay, so all we are left with are two values of A, minus 1 and 2, for which we'll have to go over the other two steps. Okay, for A equals for A equals minus 1. Let's start with that. So the reduced matrix is as such. This is minus 3. This is 0. This is 0. This is minus 1. And this is 0. It's almost reduced echelon form. So that is 1. Okay. And now, what can I say about the image and the kernel? We'll talk first about the null space and the column space. So the null space, first, the null space. So y is d, then x is 3t,
Z is 0.
and z is 0, exactly. So the null space of the representing matrix is the span of 3, 1, 0. So what is the kernel of T? For ker T, we multiply these the coordinates as coefficients of the base B, meaning that the kernel of T is 3 times the first vector of B, which is that, plus 1 time 2, 3, 4, which and obviously, sorry, the span of this, which is 3 plus 2 is 5, 6 plus 3 is 9, and 4. Okay, so that is supposedly the basis for the kernel, and the kernel is 1. Next, we do the column space. Which, because we have pivots in the first and last columns, we take the original columns of the matrix. Before we did anything, we need to take these columns. So I'll write it here. A is -1. So this is 0, this is -1, this is -1, this is 3, this is -2, this is -3, and this is 0. So the column space is the span of the first two vectors, 0, -1, 1, and -1, -2, 0. Again, you can see easily that the second column is redundant because it's 3 times the first one. And again, we need to multiply these coordinates by the basis. So, and the image of T, the actual image of T, is the span of, and then the first vector is -1, -2, 3, 4, plus the third vector in the base, which is this. Comma, and this minus the first vector, 1, 2, 0, minus 2 times the second vector, 2, 3, 4. And that is the span of -2 plus 1 is -1, -3, -4 minus 1 is -5. So the first vector, and the second one is -1, -4 is -5, -2, -6 is -8, and -0, -8 as well. Okay, supposedly that is the answer. And we still need to do it for a equals 2 as well, and we'll do it. And finally, I will put it in ChatGPT. I wonder if it can solve all of this, but I have a hunch it can. Yeah, yes.
Where do you get those 4 from? The MT equals span those?
The what again?
The MT equals span,
This?
those 4 things.
Yes. So the column space are these two vectors. What you need to do is translate. These are the coordinates because the representing matrix is built from coordinates according to the base B. So if you want to find the actual vectors, you need to take the coordinates, which are coefficients, and multiply them by the basis B. So it might have just have been 3 and 3, not 2 and 2. The reason it's only 2 and 2, because you have 0 here, where? Here, and you have 0 here. So this is only -1 times the second vector of B plus 1 times the third vector of B. And here, these coordinates translates to minus the first vector and -2 times the third vector. That's the coordinate thing, that's the last subject. Okay? And that's the last step as well. Up until finding the columns, it's easy, right? And now you need to do the translation as well. Like I said, it's important for linear algebra 2. And now for A equals 2. So again, I'm coming back here. And I'm substituting 2. So this is 0. This is 3. This is 3. This is 2. And this is 0. And will echelon reduce it? Yes. So that's 1 2/3. Z equals T. Y equals -2/3 of a T. X equals -3T. The null space of the matrix is the span of that's X, not C. So it's -3 -2/3 and 1, which I will multiply by 3. So it will be 9 2 3. And these are again the coefficients. It's not the actual kernel. If you want the kernel of the linear transformation, you must multiply these coefficients by the basis B. So it's -9 times 1 2 0, -2 times 2 3 4, plus 3 times, I never remember the third one, 1 0 -1. 1 0 -1, which is the span of now arithmetics. -9 -4 is -13, plus 3 is -10, -18, -6, it's -24. Yuck. And 0, -8, -3, -11.
Oh,
Yuck.
had to be an odd number at the end.
Yeah, right? I wanted to divide by 2 as well. Okay, yuck, but that's the answer, hopefully. Now for the column space of the matrix. So the column space here is the span of the 2 original vector columns of the matrix. Why? First 2, because the pivots are in the first 2. So I go to the original matrix, I need to retrieve it. That's the original matrix. Plug in 2, and then take the first 2 columns. So I'm plugging in 2. That's just okay. So that's 3. That's 6. That's 2. That's 0. That's, I don't care about it because I only need the first two. So it's the span of 0 to 1 and 3, 6, 0, which we can make into 1, 2, 0. I won't. I will for the next step. Remember, these are the coordinates of the space we actually wish to find. 0 to 1 and 1 to 0. And so the image of the linear transformation, we need to translate it, is the span of, and then 2 times the second vector of B plus the third vector of B, comma, the first one, 1, 2, 3, plus 2 times the second one, and all together we get the span of 4 plus 1 is 5. 6 is 6. 8 minus 1 is 7, comma. 1 plus 4 is 5. 2 plus 6 is 8. And 0 plus 8 is 8. Okay. So supposedly we solved the question. Now let's
Give it to the AI.
yeah, the AI question.
We saw this in class, right?
What?
Finding the kernel and everything.
We learned about how to find the kernel. We didn't practice it a lot, but we didn't learn how to find the kernel. We learned coordinates. These are like the last sessions.
I definitely leave the man. Going to the person. No, this. We. Sorry. One. It's the same.
We found 2 and minus 1 just as we did as the suspect values. You see the minus 10, minus 24, minus 11. And the 0, 2, 1, and 3, 6, 0. But it didn't convert the coordinates. You see, it's saying we find it in the coordinates, but we need to compute it in the 594. We have 594. Let's wait to the end. Okay. So first of all, if A is not 2 and minus 1, and the matrix is invertible, therefore the linear transformation is invertible, the kernel is 0 and the dimension is 0, the image is all of our cubed and the dimension is 3. If A is 2, that's the reduced form. Did we get to the same thing? I remember the 2/3. The 3 was there as well. Yes. Okay. So altogether 5, 6, 7, 15, 24, 24, which when divided by 3 is 5, 8, 8. 8, 8. It's the same thing we did, but I divided by 3, he did not. And here we get 594. I don't remember if we got 594 here. Wait, where is the kernel of this first? Well, yes, 594, the very same thing we did. And -1, -3, -5, and 588. 135, 588. Exactly that. And you did it quite faster than me. Okay. So yes, we solved that one correctly. Any questions? Any other questions? So that's enough for today. I wish you good luck on the test. And if you will be well prepared, I think it will be fine. And see you guys on Monday, right? Yes. Oh, but when is the next preparation meeting?
After the test. The day after, the day after.
The day after, yeah, not
Yeah,
immediately.
at one.
Great.
No, hopefully not right after. I will need like a break or something.
Yes.
Okay. Even better or worse? That's a question. Worse. Worse.